I always would like to motivate our speakers. So.
Forget the war.
Think about how it could be. A new mindset has arrived, where to share has become our greatest power.
It is this energy that guides us, will enlighten us, where meaning and purpose is a flame.
Burn inside every soul on the planet.
Welcome to the human-to-human model, uniting and inspiring leaders globally.
To build together with meaningfulness and joy.
Opening new possibilities for people.
Anticipating disruption, rethinking society.
Who will reach their potential because the future is today. Join us
To be a sustainable plus 100 world.
I think right now is clearly the way to act. Lack of clean energy will affect the Earth's core later.
I find that when people begin making small changes, they gradually get bigger because they get this feeling, I am doing something.
So we moved from greed-based civilization to human value-based civilization. Making money is a happiness. Making other people happy is a super happiness.
Wondering about your future? So bring your DNA to us today.
So if someone didn't join yet the networking system, so you're more than welcome. And just before giving the floor to Rashi, because I'm working in solar, I've been working in solar since 17 years almost. And then when we started the revolution, of course, a lot depended from the solar panels, solar modules, etc. And then at a certain point, actually the whole game changer is storage. Yes, and you saw our goals. So it's immobility, it's energy, etc. And actually the key to grow everything is storage. So I believe that today's session is so important. And I'm really honored that we can have such amazing speakers with us. So Rashi, Dr. Rashi, I give you the floor for the short introduction of the speakers, and then the floor is yours. Just we need to be quite on time with when we finish. Thank you so much.
Thank you.
Dr. Rashi is, let's say, one of the most active members in the club. Yes, as you could also notice. And she's a chair of storage and smart energy task force, but also she's chairing our Empowering Women initiative for Asia, and also is vice chair for India. So the floor is yours. Yes.
Thank you so much, Thomas. Namaste, everybody.
Namaste.
I hope you all are everybody absolutely safe. And let's begin with our session of energy storage. I'd first like to introduce Valeska, who is our co-chair today. Valeska is the head of communication and markets at the German Energy Storage System Association. She manages the association's communication and work on international market development as well as international partnerships in her role as the chair of the organization's export platform Energy Storage. Valeska holds a master's degree in East European Studies, specializing in international relations, and has a and international relations and climate and energy policy. Before joining, Valeska had supported international markets entry for German energy companies as a part of German Energy Solutions. I would then also introduce Dr. Judy Jivarajan. Dr. Judy Jivarajan is a research director at Underwriters Laboratories. She has worked in the areas of batteries for more than 21 years with a primary focus on lithium-ion chemistry. Before joining UL, she has worked at NASA Johnson Space Center in Houston for 12 years. At NASA, she was the group lead for battery safety and advanced technology. Before becoming a civil servant at NASA in 2003, she worked at NASA JSC for Lockheed Martin Space Operations for 5 years. She has a PhD in electrochemistry from University of Alabama. She has authored 3 book chapters on safety of batteries. She has won numerous awards from NASA, and the most noteworthy of them is the NASA Exceptional Service Medal and the NASA Engineering Excellence Award. At UL, she was inducted into the Henry Merrill Society as the Distinguished Member of the Technical Staff. I would also welcome Dr. Judy. I would now introduce Dr. Javier Cavada. He has joined Highview Power as CEO and President in September 2018 with a mission to drive the ambitious global expansion strategy of the company's proprietary cryogenic energy storage technology. Dr. Cavada previously has spent 17 years in leadership positions at Wärtsilä Corporation, which includes extensive international experience and executive roles in China, Italy, Netherlands, Spain, and Finland. In combination to these executive roles, Cavada has chaired the board of Greensmith Energy Management Inc. He has also held leadership roles with the German multinational firm Robert Bosch in the fields of automotive technology and manufacturing. He holds a PhD degree in the industrial engineering. Among the other awards, has been recognized as a distinguished alumni by the University of Cantabria in Spain. Welcome, sir. I would also now welcome Dr. Frank Schilling. Frank has joined Mercedes-Benz Energy in 2016. He is leading the sales department since August 2018. He has a PhD in physics and is a seasoned executive. He was a VP of sales at Siemens Communication Networks, responsible for selling soft switching and cable modems worldwide. As the head of wafer production and Cognary solar module, he succeeded in ramping and profitably operating the wafer production. He was responsible for business development at Selectra GmbH, a technology startup which was acquired by Infineon. Welcome, sir, to the group.
Thank you.
We have next with us a very unique panelist who is a startup and is Arnaud Deleli. He has graduated with a doctorate from the University of Paris in 2006, specializing in electrochemistry on battery management systems, indicators for batteries used in autonomous photovoltaic systems. He has worked as a project manager for 7 years at CEA Lytton before being the laboratory manager of the CEA Lytton laboratory, dedicated to characterization, modeling, and management of different battery technologies. He has co-founded a startup called PowerUp, which is a spin-off of CA Lytton, and he is the Chief Operating Officer of PowerUp in 2019. Welcome, sir. One of my friends that next I'm going to introduce is Dr. Rahul Valavalkar. He is the President and MD of Customized Energy Solutions in India. He leads the emerging technologies domain for customized energy solutions globally, which is under his leadership, has emerged as a thought leader in the areas of energy storage, renewables, demand response, electric vehicles, and smart grid technologies. He currently serves as a chair for Global Energy Storage Alliance. He has served as a member of National Task Force for Renewable Energies. He has also worked on drafting the National Energy Storage Mission and Battery Manufacturing Mission for MNRE and Niti Aayog in India. Under Rahul's leadership, Customized Energy Solutions has received numerous awards. Rahul holds a PhD degree in engineering and a public policy and master's degree in energy management from NYIT, United States, and has a bachelor's of engineering degree from Walchand College of Engineering in India. I would now hand over to Valeska to give an introductory talk on the energy storage markets worldwide.
Thank you so much, Rashi, for your very kind introduction. And thank you for giving me and the BVS the opportunity to make some opening remarks to our session about energy storage. By kind invitation of Professor Eike Weber, who's also honorary president of the BVS, the German Energy Storage Systems Association. I have the honor to co-chair the session about the role of energy storage on our path towards a sustainable, climate-friendly, and resilient and reliable energy system that, in light of the COVID-19 pandemic, calls even more strongly for positive clean tech disruption in those days. Energy storage is such a key technology that enables us to have a more resilient, reliable, and climate-friendly energy system. Energy storage technologies are a very smart tool, just like a Swiss Army knife, like we like to compare it at the BVS, the German Energy Storage Systems Association. Just like a Swiss Army knife, energy storage is a multifunctional tool that can be applied in so many different ways. Just as a Swiss Army knife, you got one flexible tool that can be applied in many different ways, like load shifting for on-grid or off-grid supply, black site capability, and so many more. As big as the variety of technologies is, so wide is a variety of different applications for energy storage technology, for industrial applications, to integrate renewable energies in all different sectors of electricity, heat, and mobility. In the process of energy system transformation, we are confronted with several challenges. Some of the most salient ones can be summed up as the so-called 3Ds: decarbonization, decentralization, and digitization. With the continuing success of climate-friendly energy systems that are, thanks to energy storage systems, resilient and reliable, it is becoming increasingly important to have renewable energy not only locally available, but also exactly when I need it. Renewable energies can be generated flexibly and are available everywhere, just not always. But with energy storage, indeed, the time availability is optimized. Energy storage brings the flexibility into the energy system that is sustainable and secure energy system needs. Every time, everywhere, and in every form of energy you need it. Energy storage is system relevant. This becomes even more apparent in these times of the corona crisis. In the most pressing challenges on our way towards a sustainable, climate-friendly energy system and a positive clean tech disruption can be best and most technically artfully solved with the integration of energy storage systems. I am excited to discuss in this round of experts and with you the potential of energy storage on our way to a more sustainable system. Thank you.
Thank you so much, Valeska, for the opening remarks. Let's begin the discussion with Dr. Judy Jibraman. Ma'am, could you please unmute?
Okay.
Thanks. Since you come from a standardization background and you have worked a lot on battery safeties, I'd like to ask you, what is the environmental impact that we can expect out of the energy storage projects that are coming up? And another question that I'd like to ask you is that we have seen a lot of fires in the lithium-ion batteries happening recently. So your comments and what should be done for the safety of the people and the environment with such storage projects?
Sure. So let me start with the question on the environment first. As we all know, we change our phones every 2 years or so, and so there are a lot of batteries, phones, and other accessories too. So there are a lot of batteries that are being actually disposed of, and it's I don't think there's a good education that's been spread around on how to dispose these batteries. People just throw them in the trash. But there are actually specific recycling facilities where you have to actually, where you can dispose of these batteries safely. And one of the other things that people don't realize is that you cannot mix battery chemistry. So sometimes when they take batteries to recycling facilities or recycling bins, they actually put both lead acid batteries from their cars or some other applications and lithium-ion batteries together, and that can actually cause a big fire in a lead acid battery facility if they're going to be recycling lithium ions along with it. So with respect to the environment, I think there's still a lot of learning that needs to be done. People have not understood the difference between different battery chemistries, the fact that they need to recycle these to make the environment better. So we are just starting some things on that. And as you know, tomorrow is Earth Day. And so we have put out a little, what we would call maybe a safety, message saying that people should should recycle their batteries, not only for the environment, but also, to make sure that they make use of the materials that are already in the batteries in a more useful way, economically. And then when we look at the question you asked on fires, but I guess fires are common with vehicles in general. The number of fires you see in a gas-powered vehicle is actually pretty high every year, at least in the US. And comparatively, the fires in an electric vehicle are really small, but that's probably because there aren't as many vehicles on the road as there are, gas-powered vehicles. And there's a lot that needs to be learned because, once again, there's, as we change the designs, as we change the cell types, the cell chemistries, and the cooling systems, and so on, and how these are used, where we need more and more power from our vehicle, people need to also focus on the safety at the system level. I know there's a lot of testing that's being done at the cell level. Certification documents are written for cell level testing. But when you look at the overall picture of the system level, that is lacking quite a bit. And I think if we can improve that, or at least let people understand that a system level testing is required, at least when we start designing and configuring the batteries, it'll help a lot in learning all the limitations. The same thing goes for energy storage too. We are looking at megawatt and gigawatt systems, and it's not easy to tell people, go burn up your whole battery so we can understand, or test your whole battery so we can understand how this behaves in an off-nominal condition. So we recommend that you actually test units, smaller units, that simulate everything or that have everything that a bigger unit will have, so you can understand the details of how it fails. And what we've seen is, I think just in Korea, about 28 fires of energy storage systems have been reported. And they have admitted that the system level testing has been lacking. Sorry, my throat is...
It's all right.
They have admitted that the system level testing has been lacking. One of the other things that they've also mentioned is that the battery management system is not tested, as it should be. They assume, they build a battery management system and assume that it's going to work the way they expect it to work. But what you're finding out is that, a BMS can also have limitations, especially when you're looking at protecting really high energy systems like cells and batteries, and with high voltages and high currents and so on. And so unless you test your BMS at the system level, that's also going to be a problem. So I think that's where we stand right now with respect to fires, where comprehensive testing is really not performed at various levels to understand, where the limitations of these systems are.
Right. That was quite insightful. So as of now, for the megawatt scale and gigawatt scale energy storage projects, you do not have any recycling standards or any text or any technical information available on recycling, or is there any kind of work being done on recycling of such big batteries?
So the DOE actually put out a call, I think it was last year, on recycling and also trying to extract as much as they can from lithium-ion batteries. And I have not heard about, the funding. They probably should, because this was out last summer. So they should have already assigned or given out, funding to carry out this research. But, looking around, I think people will start writing standards on renewing or renewables or, recycling as well as reuse of batteries. That's also possible, right? You can reuse batteries from automotive applications in stationary grid energy storage. And that's already being done. For instance, BMW batteries are being used in UC San Diego. That's one big example that I know of, due to a close association. But there are many things that are going on like that. But UL actually has a standard for reuse. It's called, I think it's the UL. I'll have to find out that number. I don't remember off the top of my head. But we do have a standard for reuse of batteries in the second life. And so, yeah, when you look at really large systems, one has to also think about how you're going to recycle these things. But one thing I think we do have with large energy storage systems like the stationary is a long life. They're usually installed for many years, I would say more than 10 years. So we have some time to think about, how we are going to dismantle these things and get rid of them, or use them or recycle them more effectively.
All right, now that you have come up with the second life and second use batteries, let's quickly jump to Dr. Schilling. He's from Mercedes-Benz Energy. So I'd like you to highlight the importance and usage of second life batteries, since you are into the EV company basically. So how Mercedes is looking into the dealing with the second life batteries, and you can highlight a little more on that.
Okay, thank you. Thank you for having the chance to speak in this environment. I really enjoy that, I hope. Yeah, with the second life batteries. The second life batteries are going into a second life for Daimler because we would like to make the most sustainable use of these batteries, because we found that once the state of health or the residual capacity of such a battery in the car has reached an 80% level roundabout, it is far it is not good to simply recycle it. I mean, you can get much more money out of that when you use it in a second life storage scenario. So first of all, we have a higher residual value. That means at the end of the day, the car becomes cheaper when we use the battery in a second life scenario. Now, not every battery that is coming out of the car is going straight into a second life scenario. I mean, the first thing is, of course, if you can remend the battery. So you would first remend it, then you do it in second life, then you do it into recycling. And this second life itself also can look different depending on the residual capacity and on the stress the battery has endured during its life in the car. For example, you can use it for backup solutions. That is the most kind application to a battery. You can also use it to primary control, etc. Basically, to everything, you also can use new batteries. And with these car batteries, I mean, I must say that I really enjoyed listening to Judith, hearing that these security and safety there are safety concerns in this whole field of batteries of energy storage systems. And I must say that Daimler is taking great care of trying to avoid this. Before, for example, a cell is going into a battery from us, into an energy storage system, or even in a car battery in the first place, of course, it is going through incredible due diligence process. I mean, we have the biggest lab in Europe for evaluating cells and batteries in Stuttgart. And we have a process taking between 1 and 3 years until the cells are qualified for being used in batteries. And then we have the battery development, of course, which is also taking great care. And we are proud, so to say, that we have deployed so far around about 40 megawatt hours of energy storage systems, and we had not one serious event that did constitute a security risk. The toughest thing we ever faced was some 40,000 amps from a inverter who blew an transistor, an IGBT. And so we had, for a strain of several tens of milliseconds, we had some 40,000 amperes, but our systems just switched off. So we have fuses that are fast enough to really switch it off without harming anything else in the system. So yeah, second life, as it needs to be done, in my opinion, is something that I think bears the chance to really build exceptionally safe systems, because the batteries itself are predestined to be safe, because they have proven already that they can run in a car with being shaken, with having temperature gradients of all sorts, and with running through all sorts of C rates and rough charging and everything like that. So they were made for this, and so the life in the second life is basically a recreational event for these batteries that they can really serve at the utmost level of security that is possible in today's industry market.
Okay, do you see any challenges on the second life of these batteries? What are the challenges you foresee?
Yeah, the challenge always is that for us, from a logistics perspective, you know, these batteries are basically distributed all over the world. And that is the first thing. It's the logistical thing. The next thing is that not everybody treats this or has treated the batteries in an equal way. So we have to very diligently select the batteries and group them for the various applications. For example, if you have a battery that has been stressed a little bit more, it can be easily used more like in a UPS type of application, because in UPS you don't have so many cycles. Then basically, I mean, that means not every battery can fit every application. You have to group that, and you have to get that done. I think this is basically, I mean, these two things are basically the biggest challenges, other than that you have different cars, you have different form factors, the shapes of the batteries are different, the interfaces are different. And that is actually where our company comes in, Mercedes-Benz Energy, which is 100% affiliate of Daimler. I mean, what we are doing is we are building the electronics that enable us to interface to all the Daimler batteries that are in the field, and that we can use them in the second life storage. I mean, this is really, I think, from a technical perspective, I mean, this is the biggest, the toughest challenge. And we also have integrated already batteries from Beijing Electric Vehicle, which is a company that is, yeah, I mean, Daimler holds a 4% share in BJEV. And their mother company, Bike, is holding also some chunk of Daimler. But we have also incorporated integrated their batteries into our system, and it's running well. And yeah, the point is also you have the diversity, you have the logistics, and you have the different quality of the batteries that come out of the car that you have to cope with. So this is it, basically the three factors in a nutshell.
Nice to know that second life batteries are put to good use. Let's quickly jump to Mr. Alai. Yes, we have also learned about that you have a patented technology on the management system which works in between the batteries and the charger. So could you please elaborate on that? Because now that we have learned about that the BMS is a problematic situation in the batteries and it's a cause of concern. So how does your system help and elevate the batteries' life or the performance?
Okay, hello everyone. And first of all, thanks a lot for your kind invitation. And it's a pleasure for me to take part in this very nice eConvention initiative. Yeah. So to introduce very briefly, PowerUp, it's a spin-off from CEA. And CEA, it's a famous French research and development institute working for since more 10 years on batteries, and more especially on the lithium-ion batteries. They characterize a lot of lithium-ion, and thanks to all these characterizations, they understood the aging mechanisms. And then, thanks to this knowledge, we succeed to develop a new way to charge the batteries and then to improve their lifetime. This is the first point. But the second point is also to have an innovative way to diagnose the state of health. It's a crucial point, to know the state of health, to know the remaining lifetime. So if we have a look into detail of the BMS, the battery management system today, in fact, it prevents the safety, it ensures the safety, and of course it's crucial because you need it, but in fact, it's not going to maximize the lifetime. For that, you need to have a dynamic charge, you need to know the state of health, the real state of health, and it's absolutely not done today in classical BMS. So the role of PowerUp is not to replace the BMS, of course, we need it, but we are complementary and we are going to add a technology, we call it MAP, and I am going to explain you the three letters. M, it's to measure. Thanks to CA, to a patent from CA, we can diagnose the state of health, not with a fully charged discharge and so on, because you cannot do that in a real operating situation. So we are able to diagnose the state of health thanks to partial cycling, whatever the current and whatever the temperature. This is the first point, and it's very important also for the second life. We was talking about the second life. It's crucial to know the state of health and to know also the aging mechanism, because perhaps you have the same state of health, but some batteries need to be recycled and some others can be go to a second life. So it's very important to have a very accurate state of health that we bring with the MAP technology. The second point is A in the MAP, A for act. What we are going to do is to manage the current differently, whatever the temperature, the state of charge, and this state of health. Because today BMS are very generic and very static from the beginning to the end of life of your battery. And it's not a good way to improve the lifetime. So we are going to bring a dynamic way to charge batteries. And finally, P for predict. Because today we have only some maintenance, preventive maintenance. What I call preventive is we are going to replace the battery after, for example, 4 years, but without any knowledge of the state of health. Perhaps the battery is good for 4 years again, or perhaps it is dead since 2 years. So we need predictive maintenance, and that's also a part of the MAP technology. So this is a very brief summary, and open to discussion if you have some.
Yeah. So what kind of chemistries does this work with?
Yeah, today, currently speaking, we address only lithium-ion batteries, but we cover all of the different chemistries. So manganese-based or iron phosphate-based, whatever the lithium-ion chemistries, we have a good solution to address this part of chemistry. And
So
with CA, sorry.
No, you please continue.
Yeah, with CA, we continue some research on lead acid batteries because lead acid is not dead. And so we continue, but in fact, lead acid is more complex than lithium-ion batteries because of a lot of things like a parasite reaction and so on. So we continue with the research, but today we can say that we have a good solution for lithium-ion batteries.
Okay, so is this compatible to all the lithium-ion BMS and chargers, or is there a specific type?
No, it's compatible with all the BMS, and if the BMS is already intelligent, smart, with a lot of sensors, a lot of measurements, we are not going to do the measurements, we are just going to communicate with existing BMS. If we have just a classical BMS with a PCM that we call PCM just for the safety, then we are going to add a card to do all the measurements, because this technology is based on the measurement of the voltage, the current, and the temperature. So at least we need these three measurements.
That's nice. So is this available for a commercial production right now, or it's in a pilot phase?
So we have a first project available now in a pilot. It's experimented in the field from few months, dedicated to UPS applications. So the first project is dedicated to an uninterruptible power supply system, for which we can improve significantly the lifetime, and to have a state-of-health diagnostic, and always the safety function is ensured. So it's very nice for UPS system to guarantee the functionality. And under development, we have some other projects to answer to photovoltaic systems and so on.
All right. Thank you so much for that. Let's quickly jump again to Judy.
Thanks a lot.
Yeah. So I'll come back to you in some time. So let me first ask Judy a question here. Since you said that BMS has been a challenge in the battery management, and where you because of the fire. So what is the fire mitigation plan, or you could do anything about fire mitigation in these energy storage projects? Is my next question to you.
With respect to the BMS, I think Arnaud actually touched upon this, that they can do different chemistries. I think that's very important, because when you look at lithium ion, there are so many voltage ranges that can be available based on the cell chemistry. When you look at the battery level, that's fine. You have one battery voltage, you have the same current going through a series string of cells and so on. But when you're looking at controlling individual cells and maintaining the safety, which is required for lithium ion based on the individual cell voltage ranges, then the BMS plays a big role in it. But as Arnaud pointed out, if the BMS is smart enough, then any health study that they're doing with their program will actually work very well. And I think that's going to help a lot with maintaining the safety. If people can understand the state of health, that certainly goes a lot towards towards saving the battery, not only the longer life but also the safety, right? So that'll it'll help with decreasing the number of safety incidents. One of the things I think that is very important is at this time, not having some of these programs in the field, it's very important for people to understand changes that happen within a battery. There might be subtle changes that accumulate, and then the battery goes into a thermal runaway or a fire. It need not happen when there is just one excursion of off-nominal condition. It can be a cumulative effect. So it's actually very good for these diagnostic tools to be looking out for those types of changes that happen, and then predict or give a warning early on, so they can avoid getting into a hazardous and catastrophic condition.
With this, I'd also jump to Dr. Valavalkar. There is an Indian standard coming up for BMS. Would you like to highlight something on that? Could you unmute yourself, please? Yes.
Yeah, I think regarding specific BMS standard, Rashi, I think you are more of an expert on that. So maybe you can share some insights and I can take care of the rest of the question.
All right. Well, I'd just like to say that India has just very recently published an entire BMS standard that is specific for the grid interactive energy storage systems. Specifics of the BMS standards can be dealt later on, but then this will be available as a document very shortly post-COVID, of course. Post-COVID, once we are out of the lockdown, it will be available, and I'd love to share it with all you people and see how it can shape up into the second life batteries, into battery swapping, and into the stationary storage thing. Now, when we have come for a standard and policy, Dr. Valavalkar, I'd like to ask you that how is the implementation of the energy storage policy is happening in the country? And this is not just from the perspective of the lithium ion batteries, because energy storage, when we talk of, the first thing comes into our mind is just energy storage in terms of batteries and lithium ion batteries, but that is not the only technology that is available. We have with us even Javier Cavada ji, who will tell us how other storages also can play a very important role. But before that, I'd like to hear from you what is happening on the policy and implementation front of the same.
Sure. So thank you very much for that question. So as some of you are familiar, both Customized Energy Solutions as well as India Energy Storage Alliance have taken a technology neutral approach to energy storage sector. And over the last 15 years as a Customized Energy Solutions, we have worked on range of technologies, right from pumped hydro, compressed air energy storage, thermal energy storage, liquefied air energy storage, to all type of electrochemical batteries as well as other mechanical systems, including gravity storage. So even when we created India Energy Storage Alliance, from day one, we had kept a focus that IESA will work towards creating policy environment, which is technology neutral, and let market decide which technologies they want to adopt. So we are seeing a lot of activities happening around lithium-ion batteries. At the same time, through our acceleration program, as well as some of the research work we are doing, we are continuously looking at other technologies which are coming up. And especially in India, the National Energy Storage Mission, which was drafted under leadership of MNRE, Ministry of New and Renewable Energy, was written in a technology agnostic way to cover all the technologies, including fuel cells, to be eligible for that. There is a separate policy which was written by Niti Aayog specifically for transportation sector that was primarily focused on lithium-ion batteries, because that's a consensus right now about technology of choice for automotive area. But now both these missions are getting integrated, and as part of that, we expect opportunities will be opened up for a range of different technologies. Currently, for large grid scale projects, Ministry of New and Renewable Energy has been driving projects with hybrid projects with wind, solar, and energy storage. And the first large tender, which was selected last month, actually selected both pumped hydro as well as batteries as a solution for such hybrid systems. So we expect generally the policymakers in India would take this similar approach, and depending on how fast some of these other technologies can be commercialized, demonstrated, and deployed, we can actually see multiple technologies getting integrated in the market. At the same time, given the scale of manufacturing which is happening with lithium-ion batteries, that is expected to have a larger share as we are seeing in most of the developed countries. But India traditionally has been also dominant on lead-acid batteries, and I agree with Arnaud that I don't think lead-acid batteries are going to vanish overnight. There is actually a lot of innovation happening on the advanced lead-acid batteries. Unfortunately, most of the manufacturing companies have been facing the classic innovators dilemma, and they have actually not brought some of the technologies which are proven at lab scale to commercial level, thinking that they will be eating into their own market. And that's where actually they are suffering more. So we are looking into some 2-3 interesting advanced lead acid technology as well. And particularly for applications related to the backup or reliability, I think some of those technologies can still very well continue to be part of the market.
Awesome. So what do you think is the roadmap for quality deployment of these policies in India and of course abroad?
Sure. So in terms of the roadmap, I think around the world, we see a lot of differences. Like for example, in US, the deployment of advanced energy storage technology started with creation of policies for markets such as ancillary services, and that ended up kickstarting the deployment of advanced storage technologies. And then now the hybrid projects with solar and storage or wind and storage has been leading the way. In India, since there is actually a lot of challenges faced by customers on especially commercial and industrial side with power reliability, we are seeing actually opportunities on both sides. So on one side, yes, there will be some of this policy driven deployment of grid scale projects which will happen. And we are also anticipating Indian regulators, the Central Electricity Regulatory Commission, start procuring ancillary services soon. So those type of opportunities like in US will come up in India as well. But at the same time, we are seeing a lot of opportunities in India related to diesel generation minimization or integrating renewables on commercial industrial customers, because some of the audience may not be familiar. In India, typically commercial and industrial customers pay the highest tariff, which is unlike in Europe or in US, where typically larger customers end up getting lower cost electricity, and residential customers pay higher tariff based on the cost of delivery. Whereas in India, the tariff is structured based on the ability to pay. And that's where, in fact, there are opportunities for integrating storage amongst commercial industrial customers. And there again, there are certain customer segments where maybe there are certain specific process requirements, where even other technologies like thermal storage can play a key role if they can be integrated with the process application. So we think the adoption in India will be driven both sides. In fact, we are counting more on the industry-driven adoption in India. The good part is the policy environment and some of the challenges or hurdles which are there, they are slowly getting removed by the policymakers. So that is a welcome step.
Are we looking at any timelines?
So in terms of the timelines, I think already in India, the deployments have happened. As you're familiar, in India, in last 3.5 years, there is more than 3.5 gigawatt hour of advanced batteries have been deployed. And we are now expecting the last missing piece is financing. And that's area where India Energy Storage Alliance, as part of the Global Energy Storage Partnership, has been working with World Bank as well as under the Climate Impact Fund Technology Assistance Program, working with 7 other donor agencies to try to come up with financing models for energy storage deployment. And we think within next 6 months, some of those financing schemes will be announced. And once that is announced, we expect the deployment should pick up.
Okay. Thank you, Dr. Valavalkar, on this. Let's quickly move on to our next speaker, Javier Cavadat. We would just like to see, there's a lot of discussion around batteries, and when everybody says energy storage, the first thing comes to the mind is batteries. However, that's not the case. So you have a fantastic cryo battery technology, and it's not the electrical storage, it seems. It's something different. So we would like you to please highlight something about it. Typically on what kind of sizes we can expect into this cryo batteries, and anything specific that you guys are focusing on.
Thank you very much, Dr. Rashi. I mean, it's a pleasure to be here in this eConvention. I mean, from London to the world and connecting so many places. And I mean, I've been, as you were introducing me, 2 decades in the energy industry, of course, building gas plants, also building lithium-ion batteries. So I've been heading one of the largest integrators in the world of batteries that has a second life battery agreement with Hyundai Motor Company. So it was Greensmith Wärtsilä Group and Hyundai Motor Company using the second life batteries. I mean, I was very thrilled to listen to Dr. Gervayan and to Mr. Schilling about the Mercedes-Benz and the second life batteries. I've been building a plant with lithium-ion batteries second life that I remember was like 10,000 cells of the 10,000 cars with very different treatment of every single cell. I really remember it was the heaven for engineers and hell for the business people in a way, in our view. So, but we see that energy storage is fundamental. It's really fundamental. All what we are discussing here is crucial to enable wind and solar integrated globally, as much energy storage as possible. And definitely everybody, we all, I mean, me, households, industries, we all talk about lithium-ion and about electrochemical batteries. But if you look at real numbers, 99% of the global megawatt hours installed today in 2020, they are pump hydro, they are really hydro plants. So, and the reason is scale. I mean, so the issue with lithium-ion is that lithium-ion is the best in speed, is the best in modularization, and we are all convinced that for a small scale, and we can discuss what is a small scale or what do we call a small, and short duration, we can also discuss what is short duration. I would say, as long as you need to drive a car, I would say that's the short duration. I wouldn't say, because that's where the technology is being developed. Batteries do a fantastic job, but it's like decarbonizing the planet, building gardens and putting a lot of beautiful flowers. It looks great, but I mean, you need to start thinking in trees and forests, and you need really gigawatt scale energy storage. And that's, I mean, we have a technology that is fully complementary with lithium-ion batteries. So we bring the bulky, long duration, large scale energy storage. So, I mean, some of our engineers, they say it's a pump hydro in a box, in a way, or pump hydro in a suitcase. We travel to develop projects. So, and this is a cryogenic energy storage. So it's using liquefaction technology. So very well-known thermomechanical technology from oil and gas industry. So we cool down a gas, but the gas we use is air. I mean, that's the key, that we store the energy in air that is liquefied. So we take the air that is in the environment, cool it down by compression and by temperature until it liquefies. Extremely standard process in the global industry to produce oxygen, to produce nitrogen. And as you know, nitrogen, oxygen, and argon are the main components of air. So we use those off-the-shelf components made by tiny companies like Siemens and General Electric and ABB and Atlas Copco. So our partners, we compress the air by temperature. So we're talking about minus 190, 196 Celsius degrees. So pretty much the same. You have a liquefaction or a gas terminal or LNG terminal. So you store your energy in a very energy dense mean, that is liquefied air. So just to give a sense of ratio, proportion, 700 liters of air in the gaseous state, like what we are breathing, is less than 1 liter in liquefied. So it's 700 times compressed, and it's compressed by temperature. So you just put it inside of standard tanks insulated, like the ones you can see in hospitals, you see in factories, tanks to store propane, butane, LNG, oxygen, nitrogen, but it's air, which is, since majority of it is nitrogen, it's very inert. So, and you can have megawatts, gigawatts, and the key thing there, as many hours as you need. And we're not talking about 1, 2, 3, 4 hours. We're talking about 8 hours, 10 hours, 1 day, 2 days. I mean, as much as you require. So when you need it back, you can store it for hours, for days, for weeks, for months, but when you need it back, you gasify again. So you gasify again, so warming it up, so it multiplies 700 times in volume, and it blows a steam turbine that is as rare and as unknown like the ones that are produced by Andritz, by Sumitomo, by Mitsubishi, by GE, by Baker Hughes, by Siemens again. So the same common suspect. So what we do is having an industrial assemble of technologies that are very well known from the gaseous and power industries to put them together to store energy in large scale and long duration. So we don't look at projects up to 4 hours because lithium ion is there very, very good. So we look at projects 5 hours, 10 hours, 12 hours. I mean, there is not really too many larger because we're normally coupled with wind and solar. So, I mean, if you have 10 hours, it's normally a very good deployment. And we look at the standard pieces of equipment. So then we take equipment that is fully demonstrated for the last 50, 60 years in the oil and gas industry. So we're talking about the standards from 25 megawatts, 50 megawatts, 100 megawatts. So we don't look for this 1 megawatt or 10 megawatts. No, that's very tiny for us. So and when you were asking about where the markets are, I mean, you can imagine. I'm personally honored to be elected member of the board of directors in the USA Energy Storage Association. So I mean, US is, I would say, by far the largest market for us today because of the wind and solar penetration, but also due to the regulation. So, I mean, is any place that would love, would pay the services of a pump hider, that's the place where we come, because we do the same as a pump hider. The thing is that we don't need 10 years to develop the project. We don't need a large amount of water. We don't need any distance between heights to put the water and pump it up. And we don't have any, frankly, we don't have any environmental concerns. So the most exotic component of our system or element is stainless steel. So everything talking about recyclable, etc. So it's all can be very local. All don't really, they're really infrastructure that is very thin. You would call it copy paste, like IKEA or like Lego. So we simplify to 50 megs, 100 megs, 5 hours, 10 hours, 15 hours. And we have 2 plants running in the UK, and we are constructing one of 250 megawatt hour in the UK and one of 400 megawatt hour in the US. And I can say that this technology probably 5 years ago was already proven, was ready, but there was no market because there is no need for energy storage until the integration of renewables is disturbing everything in a positive way. So, but we are the ones who, I mean, I heard from Valeska about, and also from France at the beginning, talking about the Swiss Army capabilities of Swiss Army knife capabilities of storage. The storage doesn't generate, and that's the thing that the regulators and the politicians and the utilities need to understand. Storage is to solve all the problems that an intermittent and unreliable generation provides, but don't expect storage to generate, because the regulation for the storage needs to be for storage.
Right. Thank you so much for that wonderful introduction. Now that we all have understood the different technologies of storage and that we know that energy storage is here to stay, let's quickly take a poll question of here, which is on your screen, and you have exactly 30 seconds to vote. Okay, there. So now you can see the results on your screen. I'd asked, how do you think the energy storage market is going to shape up post-COVID? So 14% people say that there'll be decrease in the markets. 71% say that there'll be a positive growth. Now that is something commendable here, which we can see that, when people are very positive about energy storage and the growth of the market, it's a fantastic outcome from this discussion. Let's open this for the question and answers that we have from the audience now. The first question is, there are many different technologies we have been discussing. However, the time is passing so fast and the conditions have been changing. Do you think we should decide some main storage systems which are easy and less expensive to implement and to work on these? Because as we all see, decreasing oil prices will be a challenge to renewable energy. So let Velesa answer this. Yeah.
Yeah, thank you. I would like to take this question because we get asked this question a lot. Which storage technology is the best storage technology? And the answer, there is no the best energy storage technology. You have to consider the application. And then when you assess the conditions of the application you need the energy storage technology for, then you find out which is the best storage technology for your decisive application. So that would be the answer. Also, this is why it is very important to continue research and development in that industry. It is a very innovative industry, and we already have such a wide variety of different technologies available on the market, and there's research done in such a wide variety of different technologies. And there will be more because we need more, because each energy storage technology has its very unique qualities and determinations that need to be assessed before you come to the conclusion which is the best technology. So the answer is no, we should not narrow the circle of selection of different storage technologies. That would be bad for the system development. And with terms of the oil price and the development of renewable energies, actually we see some tendencies towards stronger investment in renewable energy projects with energy storage systems. So I also rather see a positive development in that direction.
Okay, next question we take it. What is the feasibility of using a used electric vehicle batteries in grid battery storage system? Does the chemistry and form factor play a role in the same? Let's take Dr. Schilling. Can you take this answer? Take this question, sir.
Okay, I hope I got it right. I mean, the reason why we take NMC is because the power density is highest. We also know that there are LFP batteries who are used in cars. We also did that in the past in some prototype installations, especially for more heavy vehicles like buses or trucks. But in principle, we would always jump onto the most suitable technology when it comes to the cars. And as of present, this seems to be NMC. Did I miss a part of the question?
Yeah, he just wanted to know that does a form factor play a very important role in it?
The form
like
factor,
from
of course.
Yeah, from the EV and the storage perspective. Yes,
I mean, the form factor, of course, plays an important role. I mean, I will not now say anything about Daimler rollout because I'm not entitled to do that. But just as out of common sense, I mean, if the batteries are half as heavy and have twice as much energy, then your range is 4 times as wide. So it's very simple, you know. The form factor is of course something very important for the cars and also of course for the stationary storage. And that is one thing. I mean, basically, when you look at the second life scenarios, and we are operating such things since years. I mean, since 3 years, we now operate a solution in Lünen. That's an installation that has 13 megawatt hours of storage, second life, 13 megawatt hours. And it is clear that these batteries that you take out of the cars because of the form factor have not the power density another custom built or for ESS built solution had. But it also does not have the security of such a car battery. You know? And because, I mean, this is also interesting. Earlier we were discussing about the BMS. I mean, what we are using is, we are using the BMS of the car that is basically in this battery, built in this battery, and which is by nature really designed to be to provide an exceptional level of safety, simply due to the fact that you have a fast moving battery. Yeah. So yeah. Okay.
Thanks. The next question is for Javier. The question is specifically for you, which says, how does he define SOH? Or which parameters are used to define SOH?
I mean, I saw the question, and I'm not really sure that the question should be addressed to me. I mean, this is talking more about health and safety on,
okay, so let
on energy
him answer the
storage systems.
Yeah,
I mean, we don't have any challenge in that one.
All right, so please
I
you
can
answer the
this
question.
point
Yes.
because we developed some new tool to diagnose the state of health. So currently speaking, the state of health is the remaining capacity or energy or even power if the application is a power type. So we have in fact 3 main approaches to diagnose the state of health. The first one is to measure the voltage, but it's a very, very poor information because of course, if you are out of the range of the voltage, you can say, yes, I have a problem, but you can also have a good voltage and your battery is dead. So it's a very poor information. The second way to follow the state of health is to counter the number of cycles and to follow the time. Because usually manufacturer gives you a number of cycles and a calendar time. But again, it's a very poor information because with the same battery, the same chemistry, you can perform a few 10 cycles, a very low number of cycles, and 3,000 with the same references. So we see that if you counter the number of cycles, it depends on the usage, the real usage. So you have, again, a poor information. But that's the way all BMS operate today. So you see the point. And finally, the only very accurate way to have the state of health is to fully charge, fully discharge, but maintaining the temperature and the C rate, that means the current during the charge, the current during the discharge. And so it's not always possible to do that in the real life. That's why we have a very a point here to follow the real state of health of our battery, electrochemistry battery in real situation.
I have just unmuted you. Could you just start speaking, Bekir Akben? For your next question, wherein you have asked, can we think that the BMS will be a part of manufacturer's responsibility or private companies will involve in this? For example, will Toyota also supply services for BMS in each country, or O&M will be a part of some local private companies in each country? Now, this would depend on each and every manufacturer. Like here, when you're talking of EVs, it's a different ballgame altogether. And when you're talking of energy storage systems, it's a different part. Now, when you have energy storage system, the ESS, it depends on what you're buying or whether you're integrating it yourself. So it would be basically the responsibility of the system integrator to ensure that the BMS is functioning properly, and would also be the responsibility of the battery manufacturer or the battery assembler who has supplied this to the integrator. So I think there I have answered your question. Since you did not unmute, I have to move on now to the next question. Again, it's from you as well. In which areas will small companies take chance to involve in the storage business? See, I'll tell you, the business is available for each and every one. It's, things are available outside the mall, in the big shops and in the small shops. It's up to you what you want to choose and which markets do you want to apply your technologies and stuff into. Everything is available. Everyone has a piece and share of it. So it's not a problem. The big players and the small players, everybody can happily cohabit into the same energy storage market and have a good amount of share of business for themselves. It all depends on what you're choosing. The right technology, the right product mix can give you a good market share into the industry. Well, so we come to the end, and thank you, Dr. Valavalkar, for answering 3 questions behind. Thank you. That has saved us time, and we are absolutely on time with the session. So now to just sum up everything that we have been discussing today. So we have seen we have spoken on safety of lithium-ion batteries. We have spoken about the new technologies, of the cryogenic batteries. Then we have also spoken about the innovation of measurement device of the state of health, which is patented by the new startup Power Up technology. We have spoken about second life batteries and how second life batteries can be a very good method for energy storage systems. And we had a very beautiful poll outcome saying that 71% people have voted that energy storage systems are here going to stay. Now, post-COVID, see, we all have globally seen the effect of COVID-19. And what we need to understand here is that post-COVID, energy storage has to stay, and we have to develop new methods and new technologies to reduce the footprint of energy storage itself. That's one point that I'd like to highlight. Also, we have to see how effective utilization of energy storage can be done to achieve the second life applications, and a good research and development in the electronic technology can really help us to achieve all these points into actual implementation. On the policy front, I think all of us have to collectively work with our local governments and the central governments in each and every country to ensure that energy storage comes into the forefront of this segment, because renewable energies alone cannot help us. We need to understand that without storage, all these renewable energies and the grid cannot function effectively to give us a complete uninterrupted power supply. Basically, like our honorable PM Shri Narendra Modi ji also said, one world, one sun and one grid, which is something that we all want to achieve. I mean, if we can achieve something which is an interconnected grid across the globe, it would be a fantastic idea, and something wherein there will never be any power cut across any country. We all would be globally sufficient in energy with the kind of technology development. Like today, when we see each one of us is in a digital era, we cannot move out of our houses. We are all stuck. We cannot go. So this is a digital medium of connecting with each other. And it's a fantastic method, but without uninterrupted and assured power, this cannot happen. So we need to understand that energy storage is a very important segment to play this role. And we all really hope that together with the primary batteries, with different technologies of hydrothermal storages, or cryogenic batteries, or lithium-ion batteries, or solid-state batteries, or metal air, or any technology, but energy storage has to come to the forefront. With this, I would thank all my panelists, Thomas, Valeska, Franz, Judith, Dr. Rahul Valavalkar, Dr. Javier Caveda, our new startup member from France, Arnaud Delhi. And I'm really proud to have this energy storage session with all of you. Thank you so much. Thomas, now off to you for the final closing.
Yes, so I would like to really thank you. And we can see that 1 hour and a half, it's really a little time to, tackle the topics of storage. So for sure, we will cooperate with you together. And I would like to thank to Dr. Rashi for preparation of this amazing set of speakers. I think I always like to work with women. Yes. That's why, sorry guys, yes, but that's why we launched Empowering Women, because women are very serious, and when they are preparing something, everything is perfect. And today it was just perfect, but also thanks to the men. And actually, let me count, because 1, 2, 3. Because normally in our Empowering Women, we always have half women, half men. So Rashi, for the next one, you need to bring one more women, okay? No, but really, thank you so much. and we'll follow up. And yes, let's work together, because we cannot make this positive disruption, CleanTech disruption, without storage. Yes, storage is needed for everything. And this can happen only thanks to you guys. Thank you so much.
Thank you so much, everybody. Thank you.
Thank you.
Namaste.
It's a pleasure.
Thank you.
Namaste.
Bye.
Bye-bye.
See you soon. See you soon.
See you soon.
Bye bye.
Bye bye.
Bye-bye.